It's a neat looking function. F of x is the integer part of the cube root of x, and some examples are given. We're asked to write down the first 6 positive cube numbers. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. These are well worth learning, like your first cube number, well, first 10 cube numbers, I'd say. 11 is quite good as well, 1, 3, 3, 1. And I'm writing out 5 cubed as well because it's automatically giving me the cube root of 125 when I look at it. 6 cubed is 216. So f of 122 is going to be the integer part of the cube root of 122. And that's clearly going to be, it's not big enough to be 5. It's going to be less than 5. It's going to be 4. And we could write that, we could get it by saying that 4 is less than the cube root of 122, which is less than 5. And that is, that means that the integer part is going to be 4. I'm not going to put a box around these, but yeah, that's it. So told if x is a positive integer with f of x equals 3, find the possible values of f of 2x. All right, let's take this steady. So the smallest that x could be in this situation would actually be 3 because it's the cube root of 27, which is exactly 3. So I can write down that 3 is less than or equal, not 3, 27 is less than or equal to x. And the biggest that it could be, well, it can't equal 64. It's got to be less than 64. So it's because f of 64 is 4. So it's got to be less than or equal to 63. And then from that, we can see that 2x is going to be between 54, it can include 54, and 126. So now if I find f of 2x, well, okay, the smallest that 2x could be would be 54, and f of 54 is going to be 3, because it's not yet got to 64. And then the biggest, well, it's actually going to be bigger than 5, it's going to be 5 and a bit, so once I put it into the function, I'm going to get 5. And therefore f of 2x is going to equal 3, 4, or 5. Finally, we're asked to find all positive integer values of x such that f of x plus f of 2x plus f of 3x is equal to 10. What an interesting question. But when I did this question, I just thought, you know what, I'm going to try and find a solution. And I noticed that, well, because we're adding all of them together to get 10, why not try the smallest value x, which gives f of x equals 3. And that's going to be 27. Let x equal 27. Then f of x is going to be f of 27, which is going to be 3. F of 2x is going to be f of 54, which is also 3. And then f of 3x is going to be f of 81, which has gone above that 64, and we get 4. 3 plus 3 plus 4 is equal to 10. So x equals 27 is a solution. Now, if f of x becomes 2, there's no way I'm going to get to 10. And the reason for that is that f of x is always less than or equal to f of 2x, which is less than or equal to f of 3x. And it's growing incredibly slowly because the cube root is a very slow increasing function. So x equals 26 will give f of 26 is equal to 2, which is too small. We need f of x to be greater or equal to 3. So x equals 27 is the smallest solution. But we also need f of x to be less than 4. Because if it's 4, as I've argued here, this would then be 4 or more, and this would be 4 or more. There's no way we're going to get 10. So we also need f of x is less than 4. Okay, so we've just got to look into all the different possibility. What's the maximum going to be? Actually, we're going to need f of x equals 3, but f of 2x is also equal to 3. As soon as f of 2x goes to 4, it's going to be too big because f of 3x would also be 4 or more. So I'm going to find the maximum value, find maximum value of 2x such that f of 2x is equal to 3. And the crossover is if we get to 64, then it's too big. So it's got to be 63. 2x equals 63 gives f of 2x is equal to 3. But then x is not a positive integer. So x is then it's not an integer. Okay, so actually take 2x is equal to 62. And then x will equal 31 and we're okay. And 3x will equal 93. So then f of 2x will still equal 3 because we've not crossed over to 64. F of x is going to be still 3 as well because it's greater than 27. And f of 3x is bigger than 64 but less than 125, so it's equal to 4. And from this we get our solutions. We must have the x is greater or equal to 27, but it's less than or equal to 31. So the official solutions do this in a slightly different way. They construct 3 different inequalities for f of x, f of 2x, and f of 3x. Maybe I've modeled my way through it, but I've kind of done it, I've explained it exactly how I did it. For C, I kind of just, I did in fact just try 27. It just seemed reasonable. Got a solution. Convinced myself that it can't be any less than 27. That's what I've tried to write down here. I actually then went and looked too high an x. I started looking at the upper bound of x, where it's still equal to 3, but actually it's the upper bound of 2x equal to 3 that you have to look at. Because if you look at the upper bound of x for where just before it becomes 4, then f of 2x has already become 4 and it's game over. But if you look at the upper bound of 2x, then we're okay because we still get f of x equals 3, f of 2x equals 3, and you can get f of 3x equals 4. So I hope I've explained that okay. Neat question.